Hello everyone. Today I am going to be making a shortish video to specifically cover the endogenous growth theory part of session 7 and 8. You would recall that you would have gone over this in class, and I've also posted a video already about the convergence aspect of this session, so session 8. But what I haven't done is posted anything with respect to endogenous growth theory, so I thought I would do that. Just so that you remember, the point of the session is to understand how endogenous growth theory works, and then to make a comparison between neoclassical growth theory and endogenous growth theory. We will also look at the consequences of making the different returns to scale assumptions and whether or not these are realistic. The reason for looking and moving beyond just neoclassical growth theory and investigating alternative theories of economic growth is because of some of the underlying problems with neoclassical growth theory. Specifically, neoclassical growth theory attributes long-run economic growth to technological progress, but it doesn't really elaborate or explain how that technological progress arises. In other words, it doesn't really consider the determinants of technological progress. A bigger concern, though, is that neoclassical growth theory is somewhat problematic because it predicts that economic growth and savings are not correlated at steady state. If you recall, when we increase the savings rate using neoclassical growth theory, the consequence of this is that in the new steady state equilibrium, output per person will be higher than before, and the level of the capital to labor ratio will also be higher than before. But following a change in the savings rate, specifically an increase in the savings rate, the steady state economic growth rate will remain the same in the new steady state as what it was in the old steady state. In other words, an increase in the savings rate does not increase the overall output growth rate in neoclassical growth theory. The reason why this is problematic is because real-world evidence, the data, suggests that countries that have managed to increase their savings rates have actually increased their economic growth rates. So there is a misalignment between what the theory would predict, increasing the savings rate does not increase output growth rates, and what the reality tells us, increasing savings rates does increase output growth rates. So what we need to do is to think about economic growth and see whether it is possible for us to develop or engage with a theory that allows the link between savings rates and economic growth to be made. So we look at endogenous growth theory, and what endogenous growth theory does and what makes it unique is that it emphasizes different growth opportunities. Specifically, when it is looking at capital stock, when we think about capital stock in neoclassical growth theory, the type of capital stock that we're dealing with is just physical capital. In endogenous growth theory, however, we think about both physical capital as well as knowledge capital. When we introduce this additional type of capital, knowledge capital, we need to recognize that although there might be diminishing marginal returns to physical capital, it is most likely the case that knowledge capital or human capital will not exhibit diminishing marginal returns. Specifically, with knowledge or human capital, we would argue that there are constant returns to knowledge or human capital. The idea then that increased investments in human capital increases economic growth would be key in terms of making the link between higher savings rates and higher equilibrium growth rates. So how does endogenous growth theory work? Well, we'll look at a diagram in a second, but in terms of the production function, we have to modify the production function to allow for self-sustaining endogenous growth. We describe the economy using the production function that has a constant marginal product of capital. Remember, the marginal product of capital tells us by how much output will increase for a 1 unit change in the amount of capital stock. So the production function, let me just get the laser pointer. The production function in endogenous growth theory looks like this. Y is equal to AK, where Y is total output A is the marginal product of capital, and K is capital stock. If we assume that the only input into production processes is capital, then A is the marginal product of capital. Note though that here what we're suggesting is that what goes into capital and what we're talking about when we talk about capital stock is now no longer just physical capital, but it would also include some knowledge capital. By making this change, what we can see is that the production function and the savings curve will become straight lines, and furthermore, that both the production function and the savings curve will always be greater than the amount of investment required. The other thing that we'll note is that the higher the savings rate, the larger the gap will be between savings generated and investment required, and therefore economic growth will be able to grow faster. In terms of the diagram, what we do here is we contrast neoclassical growth theory, the top diagram, with endogenous growth theory, the bottom diagram. Just to remind ourselves what's going on, we're measuring capital per head on the horizontal axis and output per head or living standards on the vertical axis. When we're dealing purely with neoclassical growth theory, the sorts of capital that goes into the capital stock measure for the overall measure of capital per person is physical capital only. That is why we can draw the production function in neoclassical growth theory as a concave or bowed out curve, illustrating that as capital per person increases, output per person increases at a decreasing rate. Recall that the savings function then follows the same shape as the production function and that it just lies below it. We assume that we save a constant portion, S, of our output per person, and as output per person increases at a decreasing rate, savings per person also increases at a decreasing rate. Recall that the investment requirement line is positively sloped, illustrating that we need a certain amount of investment per person to maintain the various capital to labor ratios, and specifically the amount of investment required is a function of the population growth rate as well as the depreciation rate of capital. Higher population growth rates and higher depreciation rates of capital will mean that more investment will be required to maintain existing capital to labor ratios. In the neoclassical growth model, it is specifically because of the assumption of diminishing marginal returns, in other words, the fact that both the production function and the savings function have this bowed out or curved concave shape that causes the steady state equilibrium to be reached. Remember that the steady state equilibrium shows where investment per person and savings per person equal each other and allows us to determine the equilibrium level of capital per person and the equilibrium level of output per person. In steady state, once that steady state is reached, output per person and capital per person no longer change, and the population growth rate will be equal to the output growth rate. So, in this economy, the overall output growth rate, the economic growth rate, is the same as the population growth rate. Contrast that with the diagram below, where we are still measuring output per head relative to capital per head, but it's just that here, when we talk about capital per head, what goes into overall capital stock is not just physical capital, it would also include probably quite a large amount of knowledge capital. Our change in the assumption about the underlying nature of the production function, namely that there are constant marginal returns, means that the slope of both the production function and the slope of the savings function are now constant, and specifically the slopes of these curves would be equal to the marginal product of capital. In addition, we then have the investment requirement line. And what the investment requirement line shows us is just as before. It shows us the amount of investment required to maintain whatever the capital to labor ratio is. More investment per person would be required at higher capital to labor ratios, and less investment per person would be required at low capital to labor ratios. Note though that because the production function and the savings function are now straight lines, in other words, they have a constant slope as compared to neoclassical growth theory, with endogenous growth theory, there will not be a steady state equilibrium. And indeed, as the capital to labor ratio increases, the gap between the savings function and the investment function grows. It gets bigger and bigger and bigger. What this suggests is that investments in capital, and specifically investments in knowledge capital, generates enough output per person and savings per person to always maintain the investment required in order to keep those existing capital to labor ratios constant. But in addition, the amount of savings which is being generated is actually in excess of the amount of investment required to keep the capital to labor ratio constant. And that's why it is always possible for capital per person to continue to increase, which would further increase output per person and savings per person, which would further increase capital per person, and so on. And furthermore, the higher the capital to labor ratio, the faster the economy can grow and the greater the living standards that are possible to be reached. And this is specifically because the gap between the savings function and the investment function gets bigger and bigger and bigger. The real big difference then between neoclassical growth theory and endogenous growth theory arises because of the difference in the assumption of returns to physical capital. Specifically here in the neoclassical growth theory, there are diminishing marginal returns to physical capital. With endogenous growth theory, when we recognize that capital stock may not just include physical capital, but may also include knowledge capital, then we can think more about constant returns. How does endogenous growth theory allow us then to make the link between increases in the savings rate and increases in economic growth? The first thing to look at is the growth rate of capital stock. In endogenous growth theory, if we assume that the savings rate, S, remember the savings rate is the proportion of output that is saved, is constant, and we also, for now, don't think about population growth or capital depreciation, and if we also assume that there's no trade or government, then all of the savings which gets generated in this economy will get directed towards increasing the amount of capital stock. In terms of the total savings, savings in an economy will be equal to the savings rate multiplied by total output. So the amount of savings depends on the portion saved as well as the amount of output or income generated. Using this, we can then look at how capital stock will change. And what we just suggested is that if all of the savings in the economy gets directed towards increasing capital stock, then the change in capital stock in the economy will depend on the amount of savings being generated. So any change in the capital stock is going to be equal to the amount of savings being generated, and through substitution, this tells us that the change in capital stock is equal to the savings rate, the marginal product of capital, as well as the amount of capital stock. Here, just recall, AK is equal to Y. If we then take that K across and divide, or use it to divide the change in K, what we end up with is the capital stock growth rate. And what we can see is that the growth in capital stock is then directly proportional to the marginal product of capital as well as the savings rate. What this suggests is that increasing the savings rate will increase the growth rate of capital. Noting here that capital stock refers not just to physical capital, but also to knowledge capital. We now need to make the link between changing the savings rate and the overall output growth rate. The overall growth rate of output, to work out what that is, we take the production function, and from the production function we can see that if we're thinking about how output is changing, output changes because capital stock changes for a given marginal product of capital. From before, on the previous slide, we now know that all of the savings in the economy being generated goes towards changing the amount of capital in the economy. So, by substitution then, the change in total output is going to be equal to the marginal product of capital multiplied by the amount of savings in the economy. As before, if we divide through by y, what we can here see is that what we are measuring is the overall output growth rate. And the overall output growth rate is going to be equal to the savings rate multiplied by the marginal product of capital. What this suggests, and let me just switch to the pen here, is that if you increase the savings rate, that is going to have a direct effect on the output growth rate. Specifically, increasing the savings rate will increase the economic growth rate. And it is this that allows us then to suggest that endogenous growth theory does a much better job of explaining the real world situation where it's been observed that countries that increase their savings rates are able to increase their economic growth rates. Remember that in neoclassical growth theory, increasing the savings rate will not increase the output growth rates. However, this does not mean that endogenous growth theory is without its problems. And one of the issues is that eliminating the underlying principle of diminishing marginal returns to capital stock is in violation of microeconomic principles. This is because if there are constant returns to capital stock alone, then there will be increasing returns to scale to all factors taken together. And I'm going to use a numerical example shortly to show you why that would be the case. The implication, though, if there are increasing returns to scale to all factors taken together, is that firms that are able to get bigger and bigger through investing in knowledge capital will become increasingly efficient, and eventually you will have a situation where a single firm would dominate various industries. So the problem that we then have with that is we don't really see a case or cases where there is single large firms dominating industries. There are monopolies, but often those monopolies arise because of access to resource issues, for example. And it's not usually the case that it is firms that have invested primarily in knowledge capital that are the monopolies. So what we need to do is then try and reconcile how we can think about endogenous growth theory but not have this idea of increasing returns to scale complicating matters. Before we get to how we reconcile that though, what I want to talk to you about and use an example for is this. Specifically, this idea that if there are constant returns to capital alone, there will be increasing returns to scale to all factors taken together. We want to just try and explain that a little bit. So I'm going to switch to the camera view. Here we go. Alright, so what we are saying here is if there are constant returns to capital, let's write that in, constant returns to capital, what would constant returns to capital look like? Well, given our endogenous growth theory production function, if we assume, we can use some numbers here, that the marginal product of capital is 5, and if we assume that the value of capital stock is 10, then the amount of output would be equal to 5 times 10, which is equal to 50. Now let's assume that we double capital stock. So capital stock is no longer 10, it's 20. What that means is that when we work out output is now equal to 5, but multiplied by 20 rather than 10. And that gives us an answer of 100. So note that when there are constant returns to capital stock, doubling capital stock doubles output. Specifically, 100 is double 50 and 20 is double 10. So doubling the capital stock from 10 to 20 doubles the amount of output generated from 50 to 100. The problem is, though, that if there are constant returns to capital stock alone, what happens if we include other factors of production? Let's consider the production function if the production function wasn't just including capital stock as an input, but perhaps also including labor. Using some of the same numbers as before, so we can assume that the marginal product of capital is 5 and that capital stock is 10, but let's now add in a value for the population size. Let's make it 10. That means that output will be 5 times 10 times 10, which is 500. Okay? Now let's see what happens if we double the amount of inputs being used in the production process. Well, if we double the amount of capital goes to 20. If we double the amount of labor goes to 20. In our equation, we now have the marginal product of capital times 20, which is the value of capital stock, times another 20, which is the value of the population size. Multiplying that out, we get an answer of 2,000. So what we've seen here is that if we double capital stock and double the population size, output more than doubles. So here, when you double K and double N, output more than doubles. And you might recall that if we double our inputs and output more than doubles, we call that increasing returns to scale. And as mentioned in the slides, increasing returns to scale is a problematic assumption because it would mean that what we should see is always in different industries very large firms dominating the market. And that's not what we observe in reality. So the question then is, how can we then continue to think about our endogenous growth theory? Is there a way that we can think about how we understand it, which allows us to rather think about constant returns to capital as the theory had been set out? And the answer is that there is, and I'm going to switch back to this view here. And what we're going to think about is that with endogenous growth theory, the way in which we can maintain our assumption of constant returns to capital is by recognizing that when firms invest in capital stock, both knowledge capital and physical capital, the benefits that they get from their investment are slightly different. A single firm that invests in physical capital stock is likely to derive all the benefits of purchasing that capital stock. In other words, when a firm invests in private capital, in physical capital stock, they have a private return. That return to that physical capital investment is unique to the firm. In terms of knowledge capital, however, when a firm invests in knowledge capital, it is likely to be the case that they will derive some of the benefits of their investments, but also that through knowledge transfer, through sharing know-how, through research, for example, that the productivity of other firms in the industry will also be raised. So when firms invest in knowledge capital, not only do they receive some of the benefits of their investments, but some of the benefits of their investments is shared amongst other firms within the industry. So when a firm increases its capital stock, it gets the return to physical capital, but the benefit of the knowledge capital is shared, and this raises the productivity of other firms. As long as the firm's private return has constant returns to all factors, then there will be no tendency to monopolization. So what we're suggesting here is that investment produces not only new machines because of investments in physical capital, but also new ways of doing things. Firms will definitely be able to capture the production benefits of their investments in physical capital. because they receive the private returns. But a firm may not necessarily capture the benefits of new technologies and ideas because these are easy to copy and they're also shared, and this would be a social return. What endogenous growth theory then hinges on is the notion that there are substantial external or social returns to capital. The idea of social returns to capital is clearly not realistic for physical capital, but it is definitely realistic for human capital. This is because when knowledge capital or human capital is created and generated, part of the contribution of new knowledge is only partially captured by the creator and the investor. From one new idea springs another, and it is therefore possible for knowledge to grow indefinitely. That's why with endogenous growth theory, we can have a situation whereby the savings function always exceeds the investment requirement line, and infinite growth in living standards is possible. Alright, the next section is on convergence, but I have already posted a video about convergence online, so I am going to stop this there. I hope to be able to also now put together some videos with regards to the aggregate demand and the aggregate supply model.